Okay, this is part 2 of the video. My recorder shut off in the middle, so here we are doing number 9. In the diagram to the right, the perimeter of the triangle is ABC is 748. Okay, it says ABC. ABC is the larger triangle, and its perimeter is 748. That tells me that I need to find my inner triangle or my mid-segment triangle. I need to figure out what the relationship is between the outer triangle and the inner triangle. So I know that the inner triangle is 1/2, the perimeter of the inner triangle is 1/2 the perimeter of the outer triangle. So if I take 748 and I divide it by 2, so I have 748 and 748, and I'm going to divide it by 2, I get 374. So the perimeter of the inner triangle is 374. That will allow me to find x because I can add all 3 sides up and find x. So 3x minus 2 plus x plus 7 plus 2x plus 15 equals 374. I'm going to add these pieces. So I have 6x minus 2. So I've added my x's. Now I'm going to add my constants. So 15 plus 7 is 22 minus 2 is 20 is equal to 374. I'm going to subtract 20 and I get 6x equals 354. I'm going to take 354 and I'm going to divide it by 6 and I get x equals 59. So 59 is here, and now it asks for the length of A to C. Well, I know that A to C is 2 times the length of x to y, 2 times this mid-segment. So I'm going to take my 59, I'm going to plug it in to 3x minus 2, 3x minus 2. So 3 times 59 minus 2, 3 times 59 is 177 minus 2 equals 175. That's the length of 1, right? This is the length of the mid-segment. It asks for the length of A to C, so I need to double. If this is 175, this is 175, then the whole thing is 350. Right? B to X. So that's just this little piece here. So again, that should match this piece here. This is the mid-segment. That's 2 of these, right? Equals 1 of these. So this is the same as 1 of these. So this, you can see that matches up. So if I want to find the length of BX, I find the length of ZY. So I'm going to take this, 2 times 59 plus 15. So 2 times 59 is 118 plus 15 is 133. The following sides make up triangle ABC. List the angles from smallest to largest. Okay. So I have my triangle and I'm going to do A to B is 5, not exactly to scale obviously. B to C is 12 and A to C is 13, and I know that across from the longest side is going to be the largest angle. So across from 13 is the largest angle. This is the largest. Across from the second largest side is going to be the second largest angle, or the middle angle. So this is the middle. And then across from the smallest side is the smallest wee angle. So this is going to be the smallest. Right? So this problem is all about the hinge theorem. And this is comparing sides and angles. So if we're looking at 2 triangles, I have one big triangle, but I also have 2 triangles inside. So if I'm looking at BA, so let's see, BAD, so I'm looking at this angle down here, and I'm comparing that to ABD, so this angle here. Now I know they look kind of similar, but remember that the shorter side creates a smaller angle, or the longer side creates the longer angle, the larger angle, sorry. Longer side creates a larger angle. So B is going to be larger than A because 4 is larger than 3, and 3 corresponds, it's going to be across from this angle. So 4 would be larger, so that means that B is larger, so ABD is larger, ABD is larger. And then I'm looking at ABD, so this angle again in here, versus CBD. CBD, okay, so then I'm looking at this angle there. So I'm comparing these two angles inside. Now this angle was across from 4, this angle is across from 7. So clearly 7 is larger than 4, so CBD is going to be larger. The alligator eats the bigger side, the bigger meal, so bigger than ABD. Okay, and then we have CBD. So CBD is, right, CBD is here, okay? And we're comparing that to BCD here, okay? And this angle is, this, of course, if this is 3, then this is 3 on this side. So C is across from 3, and then this B here is across from 7, so CBD is larger. CBD is larger. And I'm just going to go out and fill it. I'm going to say, yep, yep. All right. 2 groups of snowmobilers leave from same base camp. Group A goes 9.5 miles, I think it should say, due west, and then turns 42 degrees north of west and goes 8 more miles. Group B goes 9.5 miles due east and then turns 40 degrees, and goes 8 miles, okay, north of east. So we want to know which group goes further. So does group A further from the base camp? This is your base camp. Then group B, or is B further from A? Or are the 2 groups the same distance? Well, we know that the larger angle, right, would create a larger length, right? So if we're looking at this, so that would mean if we look inside here, so what's inside here? This would be, because this is a straight line, right? This is 180 minus 42. And this is 180 minus 40, right? So this is 40 degrees here on the inside. And this one is 38 degrees. 38 here, right? 138, sorry. 138 and 140. Oh gosh, okay. So this angle here is 138, and this angle here is 140. Let me make this a little clearer. This is 138 degrees. This is 140 degrees. Okay, so opposite of the largest angle would be the largest line. And this angle is larger than this angle, so that would be that B is further from the base camp than group A. Make sure you check your work on this one, okay? Almost there, kind of. Okay, we have find the range of possible values for x. So, again, based on the hinge theorem, this angle here, oh, now it's dark in here, just a sec. Okay. So, this angle, 58, is larger than this angle here, 50. And across from this angle is a side, and across from this angle is another side, right? And these are corresponding sides. So we know that this corresponds to this side corresponds to this side, which is necessary for the hinge theorem. You must have 2 sides that are congruent on the triangles, and then we can say across from the largest angle is the largest side. So 58 is greater than 50, so 40 must be greater than 6x plus 4. subtract 4. 36 is greater than 6x. So 6 is greater than x, or x is less than 6. So x is less than 6. And where did this number come from down here? Well, this comes from setting this. We know that this segment cannot be less than 0. It has to be greater than 0, or it can't be equal to 0 either, right? It cannot be equal or less than 0 because we have to have something there. Otherwise, you would just have an open piece. So, or you wouldn't have a triangle, right? You just have two sides. So we need it to have a distance. So 6x plus 4 has to be greater than 0 also. So subtract 4, and we get 6x is greater than negative 4. Divide by 6, and we get x is greater than negative 4/6, which is equal to negative 2/3, which is equal to negative 0.667. Okay? That's where that came from. That's where the negative 0.667 came from. But what we care about here was that x is less than 6. Okay. Consider this triangle. So we have AD, BE, so, that must be a typo, AF, BE, and DC, this is DC, our medians concurrent at Z, the center. Complete the following expression. So CD, so remember for every mid-segment, there are 3 pieces in the mid-segment. So because it's a ratio of 2, there are 2 of these, and this one, there are 2 of these, and 1 of these, right? So there is, okay, C to Z, there are 2 chunks, right? If it's a 2 to 1, then I have 2 for every 1 ZD, right? Yep, and so I can also read this, how many ZDs, I think it's easier to read it right to left, so how many ZDs are in 1 CZ? Well, we can see that there are 2 ZDs and 1 CD, okay? Again, this ratio is 2 to 1, which means you would need 2 of these to make it to the other side. Okay. I think I'm being confusing. Here we go. FA is the whole distance. How many FZs are in FA? Well, we know that there's 1, 2, 3. So there'd be 3. Okay? So 3 FZs go into the whole distance. CE. So how many, it says how many CAs make 1 CE. So CA, there's a C, that's on the side. So there's CA. How many CEs? Well, it would take 2 CAs to make 1. Did I do that right? Oh, nope, I did not. If it's C, how many CAs make 1 CE? So it would be 1/2, right? 1/2 of CA is CE or EC. Okay, 2 BFs. 2 BFs makes what? Well, 2 BFs makes 1 BC. Okay, BZ is 2/3 of what? Oh, it's 2/3 of the whole distance. So it's 2/3. So down here, this is a ratio, but this is talking about the fraction of part to a whole, not a part to a part. That's the difference. This is a part to a part to a part, and this here is a part to a whole. Okay? So BZ is 2/3 of BE. 1/2 of BC, 1/2 of BC is 1 BF or an F and FC. FZ to ZA, FZ to ZA. That's 1 part to 2 parts. CZ is 2 parts. Let's see what I was asking for. CZ, compared to CD, the whole thing. So this would be 2 parts to how many parts in the whole? 3. So it's 2 to 3. And then CE to EA. CE to EA. That's a 1 to 1. All right, the next one is based on a centroid. So we know for the centroid that if we look at this, one of these, right? So this is one segment and this is another segment, right? So if this is one segment and this equals two segments, we know that two of these must equal one of these. So 2 times 2x minus 7 has to equal 3x. Again, because two of these, if you just think about this as if this was 5, then it'd be 5 and then 5 more, right? So this is each segment. There are 3 segments for a median because it's a 2 to 1. So in other words, we have this, there are 2 segments here and 1 segment here. So 2 times this has to equal this segment here. So we get 4x minus 14 equals 3x. And I'm going to, let's see, I'm going to add 14 over here, add 14. I get 4x equals 3x plus 14. And I'm going to subtract 3x. And I get x equals 14. Okay, does that make sense? Well, we can plug it in and find out. So if I plug 14 in here, I have 3 times 14, right? So that's 30 plus 12 is 42. So that would be 42. This distance is 42. And then this distance would be 2 times 14 minus 7. This is 28 minus 7 equals 21. So does that make sense that if this is a ratio of 2 to 1, this is 21, right? And this is 42. Well, yes, that makes sense because this would be 21, the next one would be 21, and the next one would be 21. So the whole thing, right, would be either 21 times 3 or 42 plus 21. So that would be 63. Okay? All right. Number 16. So that was for a centroid, right? This one is for a circumscribed circle, which means the circle touches each vertices of the triangle. There are other things about a circumscribed circle. We have this is the circumcenter. Okay. We also know for a circumscribed circle that the circumcenter is equidistant to the vertices. Okay, so that means that this is equidistant to the vertices. So it's equidistant to A, equidistant to B, and equidistant to C. What does equidistant mean? Equi, which is equal, distant, or distance, right? So that means that this, if this is equidistant to this, and then to down here, then this must equal this, which means that 8x, ooh, goodness, let me write that again. 8x minus 2 must equal 2x plus 16. And so I'm going to subtract 2x. I get 6x minus 2 equals 16. Add 2. And I get 6x equals 18. I get x equals 18 divided by 6 is 3. Okay. Was that the answer to the question? No, they want the radius. Well, we also know that if these are all equidistant, right, then they must also be radius. The radius also, right? Each one must be radius, because if they're all equidistant, that means that if no matter where I drew it, so if I drew it here, right, and here, we know that's the radius. So it wants the radius, so I need to take x equals 3 and plug it back in. Does it matter which one? No, because you set them equal, it should be the same answer. So 2 times 3 plus 16 is 6 plus 16, which should be 22. Okay, just make sure it was the same on the other side. 8 times 3 is 24, minus 2 is 22, so we did it right. So we have, can a triangle have sides with given lengths? So remember, all the sides have to be greater, or 2 of the sides have to be greater than the third. So 7 plus 7 has to be greater than 14, but it's not. It's equal to 14, so no. And you can try the others, but you don't need to because you've already tried the two smallest. So 7 plus 14 has to be greater than 7. Yes. 7 plus 14 has to be greater than 7, right? But we've already said that no, one of them fails, so the whole thing fails. Okay? All or nothing. So 10 plus 11 is greater than 20. So 10 plus 11 is greater than 20. Check. 11 plus 20 is greater than 10. Check. And 11, nope, let's see. I have 10 plus 20 is greater than 11. Check. That's a yes. This last one, 2 plus 3 is greater than 4. Good. 3 plus 4, so 2 plus 3 is greater than 4. 3 plus 4 is greater than 2. And 2 plus 4 is greater than 3. Check, check, check. Yes. Last one. Last problem. Alright. So, talking about, this is where we bring in our definitions of, from topic 7 and 8 for incenter, circumcenter, and centroid. And they also want you to check what creates that center. So Maria wishes to circumscribe a circle about a triangle for her new t-shirt design. Okay. If she wants to circumscribe a circle about, which means around, a triangle, that would be our circumcenter, because she wants to go around or about a triangle. And circumcenters are made with perpendicular bisectors. Connor is designing a new art piece that balances a glass triangle on top of a long pole. So some of you did not get the same review on this, but it's important to know that this is a centroid, and centroids of course are made by medians, but this is a special thing about centroids. Centroids are created by medians, and the medians cut the triangle into 3 areas. So if I were to take a triangle and I take the midsegment to vertices, midsegment to vertices, and midsegment to vertices, right there is our centroid. Centroid, it's also the balance point, right? And it's made by medians. I'm not sure if that was mentioned in the Algebra Nation, but it is the balance point. This is special to centroids. Norman is installing an irrigation to a triangular field. The sprinkler will water a circular region within the triangle. Okay, so a circular region within the triangle. That sounds like an incenter or an inscribed circle. It's the largest circle to fit in a triangle. And incenters are made by angle bisectors. Lastly, Luna is redesigning a park in the center of town. The park is the shape of a triangle surrounded by sidewalks. She wants to install a monument in the park that is equidistant from each of the 3 sidewalks. Again, if we talked about, right? And so we have our triangle, this is our park, and she was okay, she wants to install a monument in the park that's equidistant from each of the 3 sidewalks. Well, we know that the largest circle that can be put in a triangle, also created by angle bisectors, is equidistant, right? It's also equidistant. Oh, my computer froze. Just a sec. Is equidistant and perpendicular to the edges or the sidewalks, right? So you guys have an example of this, I think, on a worksheet, but be very careful. So this is an incenter, and it's made by perpendicular bisectors. Again, it's an incenter made by angle bisectors. Oh gosh. So that's the end of the review. Please study all of your workbooks and your worksheets. Make sure you collect your worksheets, and good luck.